So now we'll look at same sets, but now we'll concentrate on complex numbers. That's where our concentration is for now. So we're going to the same question we're looking at. Now we're looking at its B part. It's still same question one. Now I got the B part. Let Z1 be equal to 2i. Z2 be equal to 5 minus 3i. Z3 be 2 plus 3i over 3 minus 2i. Express the following complex numbers. In the form A plus BI, where A and B are real numbers. Part 1, Z2 minus Z3. Part 2, Z2 divided by Z3 minus Z1. In part 3, the square root of Z1. Solution. Well, the first one, you have Z2 and Z3. So you just take them the way they are. So Z2 minus Z3. So you pick Z2, it's 5 minus 3i minus 2 plus 3i over 3 minus 2i. The next thing is you can avoid putting these together. Keep this the way it is. 5 minus 3i minus conjugate this one alone. So we'll do a minus 2 plus 3i multiplied by 3 plus 2i multiplying by the denominator conjugate 3 minus 2i multiplied by 3 plus 2i. Then you say, so now I have 5 minus 3i minus, we multiply the numerator now. So we do 2 times 3, and we get 6. 2 times 2, we get 4i. 3i times 3, we get 9i. And then I times I times I is equal to negative 1. So we have negative 1 multiplied by 3 times 2. So we get minus 6. Remember, this is in the brackets over 3 times 3. We get 9. 3 times 2. We get 6i. Minus 2i times 3. We get minus 6i. I times I, we get negative 1. Negative 1 times the negative that is here, we get positive. 2 times 2, we have 4. This is giving us 5 minus 3i, 6 minus 6, that is 0. So now we have 4i plus 9i, we get 13i in the numerator over 6i minus 6i, that is 0. 9 plus 4, we get 13. So this whole thing is just 5 minus 3i minus 13 into 13, we get 1. 1i is the same thing as I. Simplified to 5 minus 4i. This is the solution. A common mistake was this one. You don't go this way. You say, okay, I'm dealing with Z2 minus Z3. So I have 5 minus 3i minus 2 plus 3i over 3 minus 2i. A very common mistake was the common denominator here is 1. I mean, it's 3 minus 2i. So you put 3 minus 2i correctly. And then you say 1 into 3 minus 2i. I now have 3 minus 3, 5 minus 3i multiplied by 3 minus 2i. Correct. Minus 3 minus 2i into 3 minus 2i gives us 1. 1 times the numerator. You open here and put 2 plus 3i. Now about 80% we are not putting the brackets. If you don't put the brackets there, then the negative will only act on 2. It will ignore 3i. And that becomes a challenge. So you say, okay, what is 5 times 3 now? We get 15. 5 times 2, we get 10i. And then minus 9i. Negative times negative, that is positive. Then I times I gives us a negative. So we have a negative back. Then 3 times 2, we get 6. This is minus 6. Minus, you open now on the other side. Minus 2 minus 3i over 3 minus 2i. 15 minus 6 minus 2. That is 15 minus 8. So we get 7. 7. And then negative 10 minus 9. That's giving us negative 19. So it seems we should have, let's see. 5 times 3, that's 15. And then 10. And then 9i. And then negative 6. And then minus 2. Then minus 8i. Okay. So now we put this together. Negative 19. And then minus 3i. That one becomes minus 21i. And then we now conjugate 3 plus 2i. And then 3 minus 2i. 3 plus 2i. Giving us 7 times 3, we get 21 plus 14i minus 63i. And then I times I negative 1. Negative times the negative, we get positive 42 over 9 plus 4. Why plus 4? That's just a conjugate. So multiply 3 times 3, 3 times 2, minus 2 times 3, that is 0. And then negative 2 times 2, and then multiply by the I. So it becomes positive. So here now you add 21 plus 42, that is 63. That is 63. And then minus 14 minus 63. What is 14 minus 63? Oh, let's check. 10, that is 19. Oh, this is supposed to be 22. 22 are not 21. Okay, so we have 7 times 3, 21, and then 7 times 2, 14i, and then minus 60, 66i. Okay, and then plus 44. Yeah, over. Here you said 9 plus 4. Okay. Then now 21 plus 44, we get 65. And then minus 66 plus 14, we are subtracting. So we get minus 54i over 13 over 13. 52. When you subtract there, then now you divide. So you can divide and get 13 into 65, we get 5. And 13 into 52, we get 4. So we still retrieve this answer here. So the common mistake was when you put the minus, then you forget to put the brackets, then it becomes wrong. Even if you do the correct equation down, it will be affected by that same thing there. And then once it's affected at that stage, then you have it wrong.
If you manage.
Then we got the second one. Z2 divided by Z3 minus Z1. Here you can opt to get, you can get Z3 minus Z1. Say, okay, let me do Z3 minus Z1. What is Z3? Z3 is 2 plus 3i over 3 minus 2i minus Z1. Z1 is 2i. Now we worked out this and got 13i. Remember, we worked out this and got 13i here. We got 13i. So when we get 13i, it means that this whole thing is 13i. 13i minus 2i, this is 11i. So if it is 11i, then we are saying we are now dealing with Z2 over 11i. What is Z2? Z2 is 5 minus 3i, then over 11i. So you do a simple conjugation here. Very simple one. So you can multiply here, multiply by I, multiply by I. So this will give us 5i plus 3 over negative 11. So that when we divide, we get negative 3 over 11 plus 5i over negative 11. Or let's see the other way, you pick them the way they are. Say Z2, that is 5 minus 3i over Z3, as Z3 is 2 plus 3i over 3 minus 2i minus Z1 is 2i. So we put 1 here. Then we get 3 minus 2i down. And then we have 2 plus 3i minus 2i multiplied by 3 minus 2i. And then we go up to the numerator, 5 minus 3i. And then this is giving us 5 minus 3i over 2 plus 3i minus 6i. The negative times negative, positive. I times I, negative. So you get minus 4. And then over 3 minus 2i. Giving us 5 minus 3i over negative 2 minus 3i over 3 minus 2i. If we change this now to 5 minus 3i multiplied by, we'll switch the denominator, it becomes 3 minus 2i over negative 2 minus 3i. Giving us 5 minus 3i multiplied by 3 minus 2i over negative 2 minus 3i. So we can first multiply before we conjugate. So we get 15 minus 10i minus 9i minus 6 over negative 2 minus 3i, which is equal to 15 minus 6, we get 9, and then minus 19i over negative 2 minus 3i. Then now we conjugate, so we have 9 minus 19i multiplied by negative 2 plus 3i over minus 2 minus 3i multiplied by minus 2 plus 3i, which is equal to 9 times negative 2, we get negative 18 plus 27i, and then plus 2 times 19, that is 38. 38i, and then 19 by 3. What's 19 by 3? There's that calculation now. That is 57. So have it comes out to be positive because of the i's. So plus 57 over, down here we get 4 plus 9. So get negative 18 plus 57. That will give us 57 minus 18. That's 39. 39, and then 27 plus 38. That's 65. So plus 65 I over 13. This should give us 13 into 39. And then plus into 65, that's 5. 5i. So I've missed it on the other one. So 3 plus 5i. So where do we miss it? Let's do the first one, so that we see where the error is. Here we said Z3 minus Z1. Okay, Z3 being 2 plus 3i over 3 minus 2i, then minus Z1. Z1 is 2i. 2i over 1. So here we rationalize the first one, 2 plus 3i multiplied by 3 plus 2i over 3 minus 2i multiplied by 3 plus 2i minus 2i, we keep over 1 there. So we get 6 plus 4i plus 9i minus 6 over 9 plus 4. Oh yeah, I see. So this was 13i over 13. So it's actually I, not 13i. Okay, so minus 2i over 1. And then here we'll have minus 2i over 1, which is I minus 2i, which is equal to negative I. Oh yeah, so we used 13. That was the wrong figure there. So now Z2 over negative I. This becomes, what is Z2? Z2 is 5 minus 3i over negative I. So if it's over negative I, then what do we get? So we get 5 minus 3i conjugate, we multiply by I over negative I by I. So 5 times I, we get 5i. I times I, that is negative 1, times negative, we get positive 3 over negative I times I, we get positive 1. So this gives us 3 plus 5i. Okay. So now they are giving us the same things, which is okay. So that's how we get to the solution there. Then let's look at the last one. Part 3. Part 3, find the root of Z1. This is the same thing as the root of, what is Z1? Z1 is 2i. Now this is a complex number. Okay, so suppose we say this complex number is Z, which is x plus iy. Then we'll be saying Z is equal to the root of 2i. So if Z is x plus iy, then it must be equal to the root of 2i. So if I square both sides, then we'll have x plus iy multiplied by x plus iy being equal to 2i. So now we expand on the left, we get x squared plus xyi plus xyi minus, because of the ii, y squared is equal to 2i. So we say, okay, meaning x squared minus y squared is equal to, first I put everything together, x squared minus y squared plus 2xyi is equal to 2i. Now, two complex numbers are equal if and only if their real parts are equal and the imaginary parts are equal. The real parts here, x squared minus y squared. So x squared minus y squared should be equal to 0 because we don't have the real part on the right. And 2xyi should be equal to 2i, implying that 2xy is equal to 2 if you divide by I, divide by I. Then now we divide by 2, divide by 2. we'll get xy is equal to 1. Meaning that we'll have, if we divide by y, if we divide by x, divide by x, we'll get y is equal to 1 over x. This equation, we take it in this one. So we'll do it in this space. So now we are saying x squared minus what is y? Y is 1 over x. And then we square it is equal to 0. Meaning we'll have x squared minus 1 over x squared is equal to 0. Multiplying throughout by x squared, we'll have x power 4 minus 1 is equal to 0. Meaning x power 4 is equal to 1. And the fourth root of 1 is still 1. So x is equal to 1. Now when x is 1, it means that though the fourth root here is plus or minus 1. It says plus or minus 1. So that we go to y and say, so y is going to be 1 over plus or minus 1. Meaning y is plus or minus 1 as well. So remember, z is x plus iy. So we are saying z is equal to x plus iy, implying that we have z is equal to, when x is 1, y will also be 1. So we'll have 1i, which is just I, or z is equal to, when x is negative 1, y will also be negative I, which is negative 1. So these will be the two values of z that are expected, because we're getting the square root. That's what was expected from you on this question. So I give you a task, a follow-up, this one. Follow-up of this task is going to be, I'll give you a simple. Express 1 plus 2i over 1 minus I plus 1 minus 2i over 1 plus 3i in the form a plus bi, where a, b are real numbers. This is 1, and then 2, express in the form x plus iy given that z naught is equal to negative 3i find the root of negative 3i. This one, we agree that we submit at the same time. Submit before 0, 0, 0, 0. Oh, so when I'm starting another class here, so give me the time. Okay, a question from Sarah.
Taki, can you repeat the last question? My network was tripping.